All right, so this video is on lesson 4.4, and 4.4 is in two parts. Part 1 is the basics of solving radical equations, and part 2 is going to be a lot more complex, okay? So let's talk about how do we know something is a radical equation or not. I know that it's going to be a radical equation because I've got an x inside the radical. So what we're going to do is we are going to try to solve this equation right here. Now, this is more of a part 2 type of equation, but it's going to kind of introduce you to the process. I have two students here. I've got student number 1. They decided to go ahead and they wrote it down. And they were like, yeah, I think I'm just going to solve it. And then student 2, they did something completely different. They went straight to Desmos and they graphed it, but they graphed it kind of in a very creative way. So what we want to do is kind of justify each step. And you've seen this a lot in chapter 2 and a little bit in chapter 4. So this first step right here, you see how we're squaring each side. So we're going to square both sides. And the reason why we're squaring both sides of the equation is because we're trying to get rid of the square root. And the inverse of a square root is a square. So when you square a square root, it gets rid of it. And that's how you get 5x plus 16. But over here, what you have to do is you have to square that binomial. We will talk about that later. And that is just simplifying. So after you simplify, you're looking at it, you're like, this is quadratic. It started out as a radical equation, but now it has changed into a quadratic function. So what we're going to do is we're going to do like what we did in chapter 2. We're going to set it equal to 0. So we're going to set equation equal to 0. After we set the equation equal to 0, then you've got choices. You can use a quadratic formula if you want to. You can graph it. Now, graphing gives you real answers only. We're going to factor, okay? So we factored using the x. So the factors of negative 12, that add up to be negative 1. That was negative 4 and positive 3. So that's where those factors came from. And then after you factor it, if you wanted to solve it, you have to set each factor equal to 0. And then after you set it equal to 0, then you have to solve for x. So this one you had to add 4 to both sides. And this one we subtracted 3 from both sides. And we wound up with 2 answers. Now that makes sense because we had a quadratic equation. Okay, so student number 2, they had a very ingenious approach, I guess. It's very creative. Do you see what they did? They took the equation and they split it into 2 different functions. So if you notice, the left side is x plus 2. That one is red. And not only when they were in Desmos, they didn't say just x plus 2, they said y equals x plus 2. Because remember, in Desmos, if you do y equals, it gives you more detail. That's always a good thing to do. And then they said y equals the square root of 5x plus 16. So what they did is they graphed the left side, that's red, and then they graphed the right side, that's blue. And then they used what we've talked about already this year. If you have 2 graphs and you graph them, where is the solution going to be? That solution is going to be right here where they intersect. And we've done that before this year, except for we did it when we had like an f of x and we had a g of x. We had 2 different functions. This one just happens to be one single equation. So this is actually legitimate. You can actually do this. But here's the difference. They only wound up with x is equal to 4. The first student wound up with 2 solutions. They wound up with 4 and negative 3. Now look at this graph. So 4 is checking out, like it's there. Why is negative 3 not showing up on this graph? So what happens when you graph things? You have the ability to see the domain and range. It's much more difficult when you're looking at an equation. So when you graph it, you see how this has been kind of like cut off. That's because the range is limited. The domain is limited. So they're never, ever going to meet down here. So what happens is when you're solving an equation, and this is going to pop up in part 2, when you're solving an equation, sometimes you have something called an extraneous solution. This one will check out. This one will not. This is extraneous. Please write that down in your notes. So here's what happens. Student number 1 solved. They did all of the steps correctly. They didn't check their answer. If you don't check your answer after you solve your equation, you could wind up with an extraneous solution and you're going to miss the question on your EOC. You're going to miss it on the ACT or the benchmark. If you have the ability to graph, that's definitely the way to go. But there's going to be times where you're not going to have Desmos and you have to solve it. Just make sure that you check your answer, okay? So we're going to explain what's incorrect. It's because student 1 had a fake, we call it extraneous. Let me make that bigger. Solution. That only occurs when you wind up squaring a variable while you are solving. In part 1, which is today, you don't have to worry about that so much. A good rule in general, anytime you do a square root, any kind of even root, so square root, you have to check your answers, okay? So how would we solve this equation right here? Honestly, I would go ahead and I would graph this one right here. Set it equal to y though. So I would graph this, and then I would graph y equals 20. And after I had them graphed, what I would do is I would find the intersection point. All right, so let's talk about just in general rules here. So a radical equation is going to have a radical that has a variable in the radicand. So right here, you see how you got your little x. If the x is under the square root or under the cube root, it is a radical equation. Just because it has like the square root of 3 or the square root of 5 in your equation does not make it a radical equation. It has to have the variable in the radicand. So you got 3 big steps. Step 1 is that you want to isolate the radical. That's like the big one. You have to be able to isolate the radical first. Then you graduate to step 2. Once you get to step 2, then you're going to raise each side of the equation either by square or a cube. So in Algebra 2 in Tennessee, you're going to only just be solving it by squaring it or cubing it, okay? And then step 3, check your answer. All right, flip it over on the back. So solving radical equations, I've got 2 examples. The first one's a square root and the second one is a cube root. If you look, first thing we do is we write the equation down and look, I know it's a radical because it's got x in the radicand. They cannot do step 2 until they get rid of the 2. See how that 2 is over here multiplied to your square root? It's got to be just a square root, nothing added, nothing divided, anything. You got to get rid of it. So they divided 2 on both sides, and then you wind up with this. Step 2, square both sides, and then simplify, and then check. So let me show you how to check this real quick. So if you want to check, you're going to write everything down exactly as it starts. No changes. Okay, exactly as it started at the very beginning. And then you take this number right here, that x, and you replace that x with the solution that you think it is. So that is now a 3 instead of an x. What you have to do is you have to verify that the left side is equal to the right side. You're not solving it, you've already solved it. All you have to do is type this in your calculator exactly as that appears, and that's just going to be 4. So if you type that in your calculator, you're going to wind up with 4. Does the left equal to the right? Yes, it does. It checks out. So checking is very important. The left has to equal the right. That's how you check all equations, by the way. Okay, so the second example is a cube root. Rules are the same. You've got to make sure that the cube root is by itself. You can see that there's a -1 over there. You have to get rid of the -1. So you're going to add 1 to both sides, and that's where that 3 comes from. Once you have this isolated, then you can move to step 2. Step 2 is when you are cubing both sides. After you cube both sides, your cube root is gone. Go ahead and solve for x. You're going to want to add and subtract first, then multiply and divide. Do you have to check a cube root? You do not. Only check it just to make sure that it's accurate, not for extraneous values. So I'm going to approach these 3 examples a little differently than I normally do. We're going to do all 3 at the same time. We're going to do them by step 1, and then we're going to go to step 2, and then step 3. I do that to make a point. Just because something looks easy doesn't mean it's going to be any shorter or any longer than the other ones. So I want you to take your highlighter, and I want you to highlight the radicand of each one of these examples. So the radicand is the stuff under the square root. So I'm going to highlight this right here. So the 3x plus 10 is under the square root. That is the radicand. That is what you want to have isolated. Currently, that is isolated, okay? Second one, highlight only what is under the radical. So I only have an x here. That is a cube root. Notice how the -10 is not part of the radicand. It needs to go, all right? It is not isolated. So I want to isolate it. So I've got to get step 1 done. Something that might help you is drawing a line through your equal sign. It keeps your left and your right hand sides separated. So if you notice on the left hand side you have -10, you've got to get rid of it. It's only supposed to be a cube root. So I'm going to add 10 to both sides. Now I can see that I have a cube root that is isolated. So I'm ready for step 2. Third example. If I draw my line, if I highlight what is in the radicand, I see that I have a 3x. That needs to be all by itself on the left-hand side. That 1/5 has got to go. The +10's got to go. You've got to prioritize it in the right order. So whenever you're solving equations, you want to add or subtract first. So I'm going to subtract 10. Then I'm going to get rid of 1/5. You have to do all of this stuff. This is just step 1. Make sure your radical is isolated. Okay. Still not isolated. I still have to get rid of 1/5. The easiest way to get rid of 1/5 is to multiply by the reciprocal. So the entire side is going to be multiplied by 5. So on the right-hand side, I get -10, but the 5 and the 1/5 cancels out over here. That leaves me with the cube root of 3x. So finally, I have the radical isolated. So if you look at all 3 of them, step 1. So that first one, I didn't have to really do anything. It's already isolated. I'm ready to go. Second one, I had 1 step. The third one, I had 2 steps. You're going to have to look at every question individually. They're all different, okay? So let's do step 2. So step 2 is getting rid of the root. This is a square root. So what I want to do to get rid of a square root is I have to square both sides. Square the entire side. Now I'm going to repeat myself a lot on this. I am not squaring 3x plus 10. I need y'all to understand this. I am not squaring 3x. I am not squaring 10. I am squaring the square root. There is a square root there. I am squaring the square root. When you square a square root, it goes away. So that's left is the radicand. It's 3x plus 10. Am I squaring the 8? Yes. I am only squaring the 8. So the square of the square root goes away because those are inverses of each other. 8 squared is 64. Okay. Second one. I don't want to raise it to the power of 2. I don't want to square it because that's not going to be good enough. I have to cube it because it is a cube root. Am I cubing the x? No. I am cubing the cube root. When I cube a cube root, it disappears and leaves the radicand. Am I cubing the 3? Yes. 3 to the third power is 27. Should have that one memorized. So I'm just doing step 2, okay? And then over here, step 2 would be raise it to the power of 3. To be clear, I know it's annoying, but I am not cubing 3x. I am cubing a cube root. Cubing a cube root cancels out and it leaves a 3x. And then I'm left with negative 10 to the power of 3. That is negative 1,000. That was step 2. Step 1, isolate. Step 2, square or cube both sides. Step 3, solve for x. Now look at that middle one. It's done. It's already solved for x. But if you look at the first one though, that x, it's not close to being isolated. So I have to get rid of the 3 and I have to get rid of the 10. I have to do one before the other. We're going to add or subtract first, then we multiply and divide. So the last thing I do is I'm going to divide both sides by 3, and I wind up with 18 over here. Should I check my answer? Yes. We don't have to do that today. We will absolutely have to do that tomorrow. But if you wanted to check it, just put 18 in place of the x, and it will check out. So I got the first 2 done. This one right here, it's perfectly normal for y'all to wind up with fractions or decimals, so don't freak out thinking you're doing something wrong. So if you type that in your calculator, it's just going to feed that right back to you. So just leave it improper unless it asks you to round. Okay, I've seen your benchmark. I wasn't able to look at individual parts, but there are a lot of words. There are word problems. And I know people can get really intimidated by word problems, but here's what I do when I read a word problem. Y'all know I'm not a scientist. I don't know anything about wind velocity, blah, blah, blah. I don't, okay? But what I know is that they gave me a formula and I can deal with formulas. So I'm going to immediately write down this formula. So I'm going to put V of P. I don't know what that means yet, but I'm going to find it out. And then 6.3 square root 1013 minus P. So once I have that written down, I need to realize that, there's 2 things that I don't know what they are. I don't know what this means, and I don't know what this means. They have to tell you what they mean. They have to. And if you read it, it actually does tell you that, and it doesn't say it in so many words, but it does say that P is air pressure. It does say that. So I'm going to write that down. And y'all know I'm really, I'm good at math, but I would honestly write that stuff down because I'm not in a hurry. That means that V of P is going to be something different. V of P is going to be the velocity. Velocity is how fast something's moving. And that velocity is dependent on the pressure. That's why it says of P. So typically you would just plug in pressure. But this question doesn't have you plug in the pressure. It actually says estimate the air pressure. It says estimate the air pressure. So I don't know what the air pressure is. I'm going to have to solve for P. So I'm going to write that down. Solve for P. So if they want me to solve for P, that means that they have to tell me the velocity. Did y'all see what the velocity is in there? Okay, so the velocity is, and it tells you right here, it's 54.5. And I'm not worried about meters per second or anything like that. I'm just worried about what am I going to substitute. So the velocity is 54.5. So I'm going to go over here and I'm going to substitute. And they don't tell me what P is, but you know, that kind of fits with the lesson because I'm trying to solve radical equations, right? All of the same rules apply. What am I trying to get by itself? I'm trying to get all of this right here by itself. I'm trying to solve P, but I have to get the square root isolated. How do I get rid of 6.3? What do? Do I add, subtract, multiply, divide? Now, I heard somebody say minus, but isn't it multiplied? Like if it's written like right in front of it, it means multiply. So we're going to divide by 6.3. Okay, we're probably going to have to round a few times in your calculator, and that's fine. But when you type that in your calculator, you get 8.65. 6.3 cancels out. Now that I have the square root isolated, I'm ready for step 2. So step 2 is get rid of the square root. Okay, when you type that in your calculator, you're going to wind up with 74.84. You're going to have to round it. Just kind of no way around it. Okay, I'm running out of room, so I'm going to put it up here. Okay, I've got to get, now I'm on step 3. I'm trying to get P isolated. So I'm going to subtract 1013. When I get that, I get negative 938.16. But it's still negative, like negative P. So probably the easiest thing for us to do is divide by -1. And when you divide both sides by -1, it makes it positive. So it's estimated at 938. And it doesn't really tell me to round any particular way, so I'm going to leave it at that. Okay, so you're going to have to do something like this when you're solving tomorrow or next class or whenever you have it, part 2. This is the #1 most missed thing right here. This is totally incorrect. So what they're doing is they're saying, oh, okay, so I'm going to say x squared is x squared, obviously, and then 8 squared is 64. This is not true. Okay. I also have people say x squared minus 16, which is double not true because 8 squared is not 16. That's 8 times 2. So that's wrong. What this means is x minus 8 times x minus 8. Agreed? That's what that means. So what you have to do is that you have to multiply a 2 by a 2. So when you multiply a 2 by 2, it's going to look something like this. So you've got x minus 8, x minus 8. So when you multiply it out, you get x squared minus 8x, and then that's minus 8x, and you get 64. So remember, most popular missed answer is this. Or they might put a plus sign or whatever, I don't know. But if you look at your 2 by 2 model, you have a diagonal that does not cancel out. So the answer is going to be x squared minus 16x plus 64. Okay, let's do the second one. So now that you know what to do, you can go ahead and start out 2x minus 3 and 2x minus 3. Okay, and then just multiply it out. In your diagonal, as long as you're multiplying the same binomial, your diagonal is going to have the same 2 terms in it. You do have to combine them though. So final answer is going to be 4x squared minus 12x plus 9. So here's what I want you to do. I want you to pause the video and I want you to write down your answer and let's see if you get it right, okay? Okay, so final answer is going to be x squared plus 14x plus 49. And then right here, I'm going to factor using GCF. And if you look at your numbers differently than your variables. So your numbers are 3 and 9. You got 2 x's here and you got 1 there. So what do we have in common? We got 3 and we have an x. So I'm going to write 3x, that's my GCF, and then my leftovers, after I divide these two by 3x, I get x plus 3. The reason why I'm doing this today is that tomorrow you have to factor to solve it. So tomorrow it gets a lot more difficult. Okay, middle one. A lot of them are going to look like this. So if you have a trinomial, you're going to start out like this. You're going to find the factors of 10 that add up to be -7, which is -2 and -5. If your a is equal to 1, you just simply write down your two factors and you're done. So that's the easy one, and I'm hoping that's what you mostly get because you can do them very quickly. The last one, on the other hand, a is not equal to 1. Okay, so a is not equal to 1. Here's what we're going to do. A times c goes in the top. A times c goes in the top. B is in the bottom. A is 2. C is -3. So you have to find the factors of -6 that add up to be 5. This is a tricky one, okay? It's going to be -1 and +6. Those are your factors. Your answer is not x minus 1, x plus 6, because it is not a equals 1. You have to do either slide and divide, or you have to do box method. So to do the box method, first term goes here, last term goes in the last box. Your factors go in your diagonal. So -1x and +6x. Your factors are going to be your GCF solutions. So that would be 2x here, -1, work backwards, be x, and 3. So final answer is going to be 2x minus 1 and x plus 3.